Hi guys, welcome to this session. So in this video, we are going to understand and see top NumPy commands and methods you must know in data science. And it's like we are going to cover NumPy methods in detail. So first of all, before starting, why NumPy array? Why not list? So I'm not going into too much theoretical detail on this, but the main reason why we are using NumPy array is it consumes less memory and it is very fast as compared to Python list, and it is very convenient to use. You can just Google on this more in detail if you would like to know, but it's not necessary. So we are directly jumping into understanding its applications, its methods. So first of all, how you import NumPy? You import NumPy as NP, and to check its version, which version you are using, you can simply print np dot dunder version. What is dunder here? Double underscore before version, double underscore after version. It is called dunder version. So this is how you can do it on Colab and as well as in Jupyter Notebook. So I'm using Python version, NumPy version 1.2.21.6. So now let's jump into creation of arrays. So I'm creating a variable array and I'm going to use np.array method. So like I can simply just create one dimensional array 1, 2, 3, 4, 5. And I will just print array, and then I will print type of array using type method. And I'm going to check array.dtype. What is the data type? So when I run this, I can simply see my array is 1, 2, 3, 4, 5, and class, and its type is like a numpy.nd array. What is nd? N is n-dimensional array. And my data type in array is integer, as I passed integer into it. So this is how you can check it. And just to check its documentation, let's just look at it, np.array, and I can get the second option, numpy.org and numpy.array. So if you look at it, you can see that it takes an object inside of it. You can pass d type also, it is your choice. And there are some other parameters like this n-dimensional 0. I want 0-dimensional array. It is by default. It will just 0 means whatever you are passing, it is as it is. It's not going to add any square bracket or remove any square bracket. So if you look at it, you can see all these parameters and its explanation. And here you can see examples here, numpy.array. You can see here they have passed integer and float both. That's why it is giving float. You can see dot here, 1 dot, 2 dot, 3 dot. And here I am passing 2-dimensional list into np.array. It is creating it into 2-dimensional array. And look at this n-dimensional parameter. Instead of 0, they passed 2. So what it did, it added extra square bracket to make it 2-dimensional. Otherwise, it was 1-dimensional. So here you can see that I can also to check what is the dimension of, you can say add dot and dimensional. And if you run this, it will tell you the dimension of your array. So it should come 1 because I have 1 square bracket. So you can see that it's 1. This is how it works. Now what we are going to do, like here I passed a list inside np.array. Now I would like to pass parenthesis inside np.array. Parenthesis means tuple. I am going to pass tuple inside array. What happens? Let's check. I have removed a square bracket and then I'm again simply printing it. So you can see it's still giving me square bracket 1, 2, 3, 4, 5 because array is defined inside square bracket. There's no difference whether you pass this or square bracket. Now here I'm going to pass, instead of integer, I would like to pass some strings. Let's say some fruit names. Apple, banana, and then oranges. Let's see what happens now if I print this. So you can see my array is having this strings, and it is saying again numpy.nd array. But when I I said D type, it gave me this U7. So you can see it does take this strings as elements in a list, but it's of our no use right now. I just gave you this example, so you can skip this part. You can just understand these passing in a list as it is more important to us. So it is just a D type. You can check its documentation once on this. Now let's jump into the main part of NumPy array, which is multiple dimensional arrays, one dimensional, two dimensional, three dimensional. So let's say if you would like to have a 0-dimensional array, you can simply just pass any number inside of it and print array, and also print ar.dtype and and dimensional. So I'm again going to print this also, so we can have an idea. Like when I simply pass one single scalar element like 5, what happens? Ar is 5, d type is int64, which is true, and n dimension is 0. It's a 0-dimensional array. Now what if I would like to have one-dimensional array? Let's check. And the one more thing is I haven't shown you shape here. Let's just do this also again. Let's just copy this and paste this. And if I would like to check shape of this, what would happen? What will it give me? You can see that in shape it is giving a simple empty parenthesis because it is 0-dimensional. It is 0-dimensional. So now let's check one-dimensional array. And instead of just 5, I would like to pass element in a list, which we did earlier. So what is going to happen now? It will give me one-dimensional shape. So let's just check print array, and it is giving me 5 comma, means it's one-dimensional. If it's two-dimensional, it will add another element into it. Why 5? Because I have 5 elements here. So it is giving me 5 comma. Now, so let's see. Okay. Now here I did one-dimensional. So let me just add another cell, and instead of one-dimensional, I will add two-dimensional elements into this. Now, since when I had one-dimensional array, I had only one square bracket. Now I will just add one square bracket inside of every element here. So instead of 6, I have 7 also. So just to understand this, let me just keep some space here. Now you can see that I have list inside the main list. I have list inside main list. This is how my two-dimensional array looks like. So I hope you got the idea of it. Let me try running this, if it throws any error or not. I hope it shouldn't throw any error with this space. Since I added this to explain you, okay, this is fine. So you can see that two-dimensional array means one-dimensional list inside list. Means I have two square brackets. Like if I start walking from here, I need to pass two square bracket to reach an element here. And same from the right side also, two square bracket. So that's why it's two-dimensional. And if you check the shape of it, why shape is 3,2? Because I have 3 lists inside the main list. And I have 2 columns, 1, 2, 4, 5, 6, 7. That's why 3,2. So this is how it works. And if, let's say, if I would like to print ar.n-dimensional to confirm if my dimensions are correct or not, you can see that it says 2. It's two-dimensional. It is two-dimensional. So, and d type, you know, it's int. Obviously, if any element here, I add it as float. Let's say if I make it float, and I also print ar.dtype. So we'll see that it will say float 64, although I have only one element which is float. So that's it for like creating two-dimensional array. Let's just check three-dimensional array. So in three-dimensional array, you will have two-dimensional elements, and it means I will have these type kind of elements inside my square bracket. So let's just copy this to show you. Okay, let's not copy this. Let me just create another array. Let's say np dot array, and I would like to create three-dimensional. So I have this first square bracket. Let me just create some space here, and I will add two-dimensional array into it. So for two-dimensional array, I need to create like this 1, 2, 3, 4. This is my two-dimensional array. I have one two-dimensional. You can see that this is one two-dimensional array. I will add two more arrays like this just to make it look nice. Let's just say 2, 3 and 4, 5 and okay. This is my another two-dimensional array. So you can see that I have added two-dimensional array. Let's just add one more. 4, 5, 5, 6. So this is I have added. Let me just add one more square bracket and this parenthesis bracket. So I have created this three-dimensional array. You can see inside my main square bracket, I have two-dimensional array, three two-dimensional arrays. So this is how we can create three-dimensional array. And if you start jumping from here, you need three square bracket to reach the element. And I can simply write here print array dot and dimension. So now let me print this. So you can see I have this three-dimensional array and the shape is 322. Why 322? Because I have these two-dimensional array, like I have three of this. And inside three of this, I have two one-dimensional array. So 3, 2. And inside this single list, inside 2D array, two elements. So 3, 2, 2 is the shape. And dimension is 3. So this is how we create three-dimensional array. We have seen one-dimensional array, two-dimensional array, and three-dimensional array. And how to understand this by creating this space. I hope you got this. So let's jump into next. And here I have already created 0-dimensional, 1-dimensional, 2-dimensional, and 3-dimensional just to understand this. Just to understand this, you can see that I am creating some space here. And in 2-dimensional, I have 1-dimensional arrays. And inside 3-dimensional, I have 2-dimensional arrays. So this is how we can create and we can simply print dim and shape. And let me just show you. I have like for first element here 42, the and dimension is 0 and shape is empty parenthesis as we have seen in previous example. And for one-dimensional, I have these single scalar numbers, and the and dimension is 1 and shape is 5, why? Because I have 5 elements here. And for two-dimensional array, as we have seen, I have two simple list inside the main square bracket, and I'm converting this into array. And two single list, it means 2 and 3 because I have 3 elements inside each list. And for next example, I have two-dimensional arrays inside this two-dimensional list inside this main list. And so basically two-dimensional list and 2 inside of those two-dimensional lists. So 2, 2, 3 is the shape of the final three-dimensional array. So if you didn't get this properly, it's okay. Just try to write this code and try to keep this space and see how we are making arrays. Just try to do this by your own. You will simply get this. And you can comment below if you didn't understand this. I will try to explain again. So this is how we can understand one-dimensional, zero-dimensional, two-dimensional, three-dimensional arrays. Now, what if I would like to change dimension of my array? So here, in our documentation, when we looked at it, we had one parameter here. I just discussed some time ago, which is n-dimensional parameter. If I pass this, it will do the job for me, no matter how my array looks like. So, for example, I'm passing this one-dimensional list here to convert this into array. So, logically, let me show you. Logically, my array should have dimension of 1. So let me just show you by copy and printing this again. And if I check array dot n dimension, it will give me 1. But if I print this cell right now, if I run this cell right now, it will say my dimension is 5. How? So you can see that this n dimension parameter, it is adding extra brackets. It is adding extra brackets to make it look like 5 dimension, because I asked him to do so. Here by default, the value is 1. Oh, sorry, value is 0. It means whatever I am passing, it will give me as it is. So that's the difference when you pass n dimension 5 here. And also, this is also like here you can simply add elements of array by passing just index. So now we are going to see how to index in arrays, which is very important part of array. As when you start working using Numpy, you can go into multiple dimensions and you need to learn how to extract elements from a high dimensional array. So just to give you an insight of it, let me just again create some space. Here you can see that I have one-dimensional array inside two-dimensional inside this square bracket. I have one-dimensional arrays or one-dimensional list. And let's say I would like to extract a part of it. How will I do this? So when you have two-dimensional array, you need to do indexing on 2 level like this. You need to index on 2 level. For example, when I had array like this, one-dimensional array, and let's say I would like to access.
Sorry, I'm having trouble connecting to the internet. It looks
Just
like
one
there is an
moment.
issue with the router and echo device.
Here you can see that when I have array like this, so I have one Alexa. She thought that I'm calling her, so ignore this, guys. So let's say if I would like to index this array, I will just say array 0 or 1 or 2 or 3 to extract this. This is how I will extract this. And since I have this one-dimensional array, I need to just pass one number for indexing. And if I check two-dimensional array like this, so here I need to pass 2 numbers for each row, and for just second level, I will say that, okay, let's just understand this. Let's say you would like to go inside of this array. You first need to pass this square bracket. And then you will go to another one-dimensional list. And that's what I'm doing here. I'm just passing a number to get inside of this array, and then I will extract another one-dimensional list. So that's why I need to pass 2 numbers here. And let's just check what it is saying. Array 0, 1. 0 means I will first go to the 0th index of this two-dimensional list, and then I will go to first element of it. First element means first of this element, which is 2. So extract 2 for me. So you can see that it is giving me 2 because I extracted this 2 from here. Similarly, if I would like to extract, let's say if I would like to extract this 8 number, how will I do this? So first I will cross this square bracket. So I will say that I want to go to this list, which is first index of this two-dimensional list. Index of this two-dimensional list, and then I want this 8. Then I need to index inside this first this one-dimensional list, and 8th is at the second index. So I will say here 2, and then that's how I can extract this. So I hope guys you are getting this point. This is very important here, and just try to practice this right now. Try to extract 7, try to extract 10, try to extract 9 by yourself. And let's just go for 3-dimensional list here. Again, I'm gonna create some space that it is 2-dimensional list inside this square bracket. And again, it's 3-dimensional, so I will pass 3 numbers here. First, to cross this square bracket, second is to cross this square bracket, and third is to get into this 1-dimensional list. Similarly, 0 means I want this first 2-dimensional list. Okay, I have two-dimensional lists, so I want zeroth this. I'm saying I want to go into first 1-dimensional list inside this 2-dimensional list, which is this 4, 5, 6. And then I'm saying I want second element, which is 6, so it will print 6. So you can see that I've got 6. Similarly, you can access 7, 8, 9. So 7, 8, 9 is obviously in first index of this 2-dimensional list. And so let me just copy this again. Let me just copy this, print, and I want to access 7, which is the second 2-dimensional list inside this square bracket of 3 dimension. So I will say that I want this second 2-dimensional list, and then I want first 1-dimensional list of this 2-dimensional list inside this square bracket. So I will say that I want 0th, because in this 2-dimensional list, 7, 8, 9 list is the 0th index. And then inside the 7, 8, 9, I want 7, which is also 0th element. So if I print this 1, 0, 0, I will get the 7. So just try to understand that 3-dimensional list is made up of 2-dimensional list, and 2-dimensional list is made up of 1-dimensional list, and 1-dimensional list is made up of single scalar numbers. And when you know this, you can simply index very easily, no matter what dimensional array you have. Now let's just check one more thing. And here it is, like let's say I have this 2-dimensional list, and I would like to get last element from second dimensional, like from the second list. So you can see that how will I do this? As the first one, what is 1 means here? This is 0th index and this is 1 index. So I said 1, and then I said -1, which is the last element, as we know from our Python tutorials that the last elements can be accessed by -1, and it will simply give me 10. Similarly, I can index like a 1 to 5 index element, which is 2, 3, 4, 5, 6. Not 6, because last element is not counted. So I can simply index some part of an array using indexing, just like we do it on list. It simply works similarly like that in array also, like from -3, -2, -1, which is 5, 6. So negative indexing happens from the last. If you don't know, 7 is -1, 6 is -2, 5th is -3, 4th is -4, and so on. And I'm saying -3, -1, and by default here space is 1. You can change it, and if you don't know about indexing, it's okay. Just remember that we pass 3 numbers: start, stop, step. Start, stop, step. Let me just comment this here. Start, we pass start, from where we want to start and where we want to stop, and how much step I want to go. By default, step is 1, so you can simply change it. Let's say if I say here I want every second element, it won't give me 5, 6. It will just give me probably one number, which is 5. Yeah. So this is how it works. Let's say if I don't pass this element, it will cover last element also, which is 7. It will give me 5, 7. So just check it once if you don't know about this indexing. And if you don't know, I will send you some link in description if you would like to have. Just comment below if you want to know on this more. Now our let's I have given this one more example. Let's I have this one more array, one dimensional array, and I am saying 1 to 5 by step with 2. So from 1 it is 2. Now it will give me every second element, 2, 4, 6. It will give me every second element. Okay, it is not giving me 6 because I said from 1 to 5. 1 is 2, 2, 3, 4, 5, and 6 is not included. That's why it is giving me only 2 comma 4, because the third element is 6. 6 is not included. Let's say if I change it up to 7, it will give me 246, as we talked earlier. So, and again, you can simply avoid passing start and stop. So it will start from 0 and it will go to the end every second element, which is 1, 3, 5, 7. So it will give me 1, 3, 5, 7. Now again here I'm extracting a part of an array using indexing. So what I'm doing here, since it's two-dimensional array and we have already discussed that we pass two numbers, but you may wonder like why we are passing like this 1 colon 4. So what's happening here is I'm saying 1. What is 1? Which is this second list inside this two-dimensional array, and I'm saying 1 to 4 means 7, 8, 9, 10. 10 is not included. So it will give me 7, 8, 9. So you can see that you can index, you can extract from an array like this also. This is amazing. Again, instead of doing this for second number, you can do it for first number, and it will give you 1 to 1 to oh sorry. So 0 to 2 means here is you are choosing this and this both list, this and this both list, and you are saying every second element. What is second element is 3 and then 8, second element in both list. So when you passed with colon like this, you are talking about a single list. You are talking about a single list whose indexing depends on the first number. But here, if you pass with a colon like this, you are simply saying that you are gonna work on uh, all the list inside this here, and then you are saying every second element. So 3 comma 8. So guys, this is quite tricky for the first time if you are looking at it. But don't worry, just type this code and observe, play with the numbers, change numbers here and see what's happening. This is how you learn. And let's just check one more example on this. I'm saying 0 to 2. It means I want 0 and 1 both list inside this two-dimensional list. And what I want from first to third element, excluding 4. First, which is 2, second is 3, and third is fourth. So I want 2, 3, 4, and I want 7, 8, 9. This is what I want here. And you can see 2, 3, 4, 7, 8, 9. So guys, just practice it like this, just like I'm speaking right now and I'm explaining it to you, explain it to yourself, and it will work like magic. You will understand everything. Even if you do mistakes, it's okay. We all do mistakes. I have done a lot of mistakes understanding this. Even while teaching, I might have missed something and then I fix it. So let's just go with it. Now let's just see our this topic, reshaping array. And reshaping array here means whatever shape or whatever number of elements you have, you are gonna maintain it, but you are just going to change the dimension. For example, here I have 12 elements. 12 elements. So let me just copy this to you to explain you, and let me just print it here. And I am saying array dot shape, and you can see that I have shape 12 comma. Now, if I want to shape it to two-dimensional, right now it's one-dimensional, and I'm going to shape it two-dimensional. And if you multiply this 4 comma 3, it's 12. So it should work. It will work, and it will change it to like this. And if I simply print array here, so you can see that. One moment. Let me print this also. Print array dot shape, and And you can see that right now my array is this one dimensional, and its shape is 12 comma. But now I have got one extra square bracket from both sides, and my shape must have changed. New array dot shape. But the main common thing is if you multiply 4 comma 3 and it's equal to 12, that must be maintained. That must be maintained. You cannot have 13 elements here and the shape is 4 comma 3. You cannot have that because 4 into 3 is not 13, it's 12. Now I'm gonna reshape the same array into 3-dimensional, and you will see that you will see that you will see that my array has 3 square brackets in the end. In the end, I need to pass 3 square bracket to reach to the first element. And but shape is different. It's 2, 3, 2. But if you multiply 2 into 3 into 2, it's equal to 12. That must be maintained. That's how you reshape it. And it's amazing. So you can see that we can reshape an 8 elements, one dimensional array into 4 elements in 2 rows, 2D array, but we cannot reshape it into 3 elements, 3 rows, 2D array, as that would require 3 into 3, 9 elements. So your overall number of elements must be maintained in a proper shape. I mean the dimensional shape, the square of their numbers must be equal to the main equal number of elements. So let's just check one more example. For example, here I have 8 elements. So I can reshape it into 4 into 2, 2, 2, 2, or 2, comma 4. I can reshape it like them, or the 8, comma 1. It's equal to same right now. So, but I cannot reshape it into 3 into 3. You can see that it will throw error. It will throw error. You can see its value error, cannot reshape an array of size 8 into shape 3, comma 3. But you can check. Let me show you. If you would like to reshape it into let's say 8, comma 1. Let me show you the right now what is the shape of it. Print old shape, and it's array dot shape, and now I have reshaped it into like this, and let me new array dot shape. So you can see that right now my shape is 8 comma, and now my shape is 8 comma 1, but 8 into 1 is 8. So you can see that it's 1 dimensional, it's 2 dimensional. So but you cannot shape it into 3 into 3 because 3 into 3 is not equal to 8. So that's how you can reshape an array into whatever dimension you like. And just try with some different shape by yourself. Try with a different shape. For example, I can again reshape it like, let's say 2 comma 2 comma 2. Let me show you array also so that you get feeling, with in understanding it. And this is my array, and I'm going to print again here also. Now my new array, and let me just have this new array, and again after doing this new array dot shape, new array, new array. So you can see that my current shape is this, and this is the dimension, 1 dimension. This is 2 dimension. You can see that I have got 2 square brackets here, and here I have got 3 square brackets, and the shape is 2, 2, 2. So I hope you got the idea how you can reshape it. You just need little more practice on it. Just get a hands on, check more examples on Google. It will help a lot. Now there's another way to reshape your array, which is you just pass whatever you want in the beginning. For example, I have 8 elements here, so I must have the shape of, or like I must have shape in such a way that they are multiplying those numbers equal to 8. But what I did here, I passed 2 comma 2. I said last dimension I leave it on system, whatever they wanna pass. So you can have one unknown dimension, which is I said -1. I don't know. It will find automatically. For example, 4 into 2 is it, so it will be 2. So it will just do it by on. You can see that I had the similar output here. This. So it did it by itself. It did it by itself. So this is, you can pass one unknown dimension. You can simply here also say, like, let's say I just say -1, 2, -1. So it will make it 2 dimension 2, 4. You can see that, it just chose by default 4 element to equalize it. It's like it's multiplication. So it equalizes by itself. So this is how you can have an unknown dimension by passing -1. This sounds might confusing in the beginning. Just try it, play with it. And for example, let's say I say here 4. Now I will have 4 rows. I will have only 2 columns. So you can see that now I have 4 rows, 2 columns. So you can play with it just to understand. And like for example, here I said just -1. I said just -1. So it will make it one dimensional. I will have 6 elements. So this is how it works. So now we will see how we are going to loop over NumPy array. So for example, here I have taken this two-dimensional array, and we know that two-dimensional array is made up of one-dimensional array or list. So and I want to loop over it. So for example, if I say for x in R, what an R consists of? One-dimensional list. So when I said for x in R and print x, it's gonna give me this list. And how many lists I have here? I have 2 lists here. So if I run this, I will get 2 lists. Similarly, if I say here, again I have this same list, and instead of just for x in R, I say that for y in x. So for x in R, print x, give me this list. I have 2 lists. And then I said for y in x, what is x here? X is this. So for y in x means I'm gonna print 1, 2, 3, 4, 5, 6. Because for x in R will loop over 2 times here, because I have 2 lists inside this two-dimensional array. And I said for y in each list. So first it's gonna print 1, 2, 3, and then 4, 5, 6. So you can see that how we loop over array. Same rule applies for three-dimensional array. Three-dimensional arrays consist of two-dimensional arrays. So I have two-dimensional array here. How many? 2. So it's gonna print 2 two-dimensional arrays. You can see that I have both two-dimensional array here. And again, now if I want to extract each element, I will first say I want for x in R means 2 times here, and for each two-dimensional list, I'm going to say for y in x, which is this one-dimensional list in each two-dimensional list. And I said for z in y, then it's gonna print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I hope guys you got the idea here how we are looping over on it. Now let's go on our one important topic. Like many times when you are working on a data set, you need to concatenate things, and here concatenation of array comes into handy. I want to concatenate here. So before going into that, let's just check documentation of np.concat. So you can see that I have got this documentation. So it's saying that numpy.concatenate takes like this arrays like this, and then by default x is 0. X is 0 means our rows. So default is 0. So what does axis say? Axis along which the arrays will be joined. If axis is none, arrays are flattened before use. Default is 0. Now let's just check one example. Here I have this example, 2 arrays. I'm saying x is 0, concatenate a comma b. So it will just concatenate 1, 2, 3, 4, 5, 6 like this. You can see that. Now for example, if you say axis 1, but you are transposing the second array using b dot t, then it will concatenate like this. So I'm going to show this to you. This is concatenation is an important thing here. Let's just say I have this array 1 here, and let's say I print this array1 before transpose. So let's say array1. Now I said array1 equal to array1 dot t, and I have transposed this. Now if I print array1 after transpose, now array1, let's just check this. So here transpose didn't work much. Because it's one dimensional. Let's just say for 2 dimensional here, or instead of just doing this, let me just try like this. Yeah, it's 1 dimensional, so it didn't work here. Let's just try, and here np dot array, and I have 2 dimensional array 1, 2, 3, and then 4, 5, 6. Now if I just print this here, now here you can see that it worked. So what happened here, you can see that here 1, 2, 3, 4, 5, 6. Let me just check. Let me just show it in a nice way. Yeah, again here also \n in a new line. So here you can see that my normal array is this 2 rows 3 columns, 2 rows 1, 2, 3, 4, 5, 6, 2 rows 3 columns. But here when I transpose this, what happened, it changed my number of rows into number of columns. 2 rows converted into 2 columns, and 3 columns converted into 2 rows. In short, my dimension was 2, 3, and after transpose it became 3, 2. That's how it works, transpose. So you can simply call t to transpose. Now it will come in handy in our coming step. So now we were discussing about concatenation. Now I said concatenation works like this. I have these 2 1-dimensional arrays, array1 and array2, and I concatenated. So it became 1, 2, 3, 4, 5, 6. Because by default axis is 0. By default axis is 0. So it worked like that. Now since it's one dimensional list, and let me just copy this. And instead of axis 0, I say axis 1. So you can see that axis 1 is out of bounds for array of dimension 1. So you can see that for dimension 1, axis 1 is out of bounds. It doesn't work on that. And why is that? Because its dimension is 1. If you concatenate like this, you need to have 2 dimension. So for example, let's say I say here, so since it threw error, let me show you, let me just copy this again. Let me show you how we can make this work. If I say here, and dimension is 2, and dimension is 2. Now, let's check now. Okay. Oh, actually it's not 1 dimension. np dot array. What was the term we used? ndmin. Ndmin actually. ndmin. min and d min here also. So now it should work. So you can see that it worked this time, but still it didn't work in a way I wanted. It didn't work in a way I wanted. So now let me check what does it for 0. Ah, it's working in a different way because I have square bracket like that here. So axis 1 works in a different way. So you can see that you can make it work by changing some parameters. So you can see that previously it concatenated array in this way, in one dimensional way, in along the axis like this axis 0. Now it did in axis 1 in this way. Now let's go to our next step. Here I have two dimensional arrays and I'm concatenating along axis 1. So it will give me output like this, and you can just to make it look more prettier, you can just say add1 before concat. So like when you are watching this, I highly suggest you to please type this code to understand. And you can see that although I have written code here, but I'm trying to make it look nicer so that it becomes clear to you. So add1 add2 before concatenation, and then after concat along axis 1. So this is my array 1 before concatenation. This is array 2, and it became like this 1 2 5 6 3 4 along axis 1. Now if I do the same thing, along axis 0, instead of like this horizontally, it will be embedded like vertically. So let me just change this, and you can see it is embedded, it is concatenate like this. So this is how we can concatenate. We have seen documentation also. Let's go to our next step, which is stacking array 1 and 2. So let's just see how the output of this. You can see that it is stacking like this: 1 4 2 5 3 6. 1 4 2 5 3 6 is like 1 2 3 and you can see that it's one dimensional, but the output is two dimensional. So let's just check its documentation. np.stack, and if you check its documentation, again by default axis is 0, and you can pass arrays. And if we look at the example, np.stack a comma b, it is giving like this. So that's how it works. Let's just look at this. So now again, how to play with the parameters. Instead of axis 1, let's just check with axis 0. So obviously you know that right now it's like this. It will be more on the horizontal form. It is more on the horizontal form. Here we saw that it gave me output like this because by default axis is 0. By default axis is 0. So even if I don't pass this parameter here, the output will still remain like this. But here I passed axis 1, so I got output in this vertical form. So this is about stacking. Now even in stacking there are other there are np.hstack method, np.vstack method. So it will just simply do it horizontally, 1 2 3 4 5 6. I think it's more visible to you right now because h is horizontal here. Now if you see vertical, it will obviously do vertical like this. So just look at its documentation and parameters by yourself, If you have any doubt related to this, comment below. I will answer there. And HStack, VStack, it's quite helpful. You must know these methods. Let's go to our next point, which is splitting an array. And np.array split method takes two parameters. First is array, and in how many parts you would like to split this. So here I said I want it in 3 parts. So just by looking at it, you can see that it's 2-dimensional array, and it has 6 one-dimensional list. I can simply divide it into 3 by 2 list. So if I do it, it will give me like this: 1, 2, 3, 4. Obviously, 5, 6, 7, 8. Obviously, it seems pretty clear. 19, 11, 12. So let's just check its documentation. 1 np.array split. You can see that I just got this in search bar, and it's array, and this is our sections or axis 0. So how many sections you want? Split an array into multiple subarrays. So if you see that, if I say np.arrange, arrange method is it's like a range method. It creates a list of numbers to you. It again takes 3 parameters: start, stop, step. If start is not defined, it's by default 0. Step is not defined, it's by default 1. And you just need to mention and. So let me show you this example also. Since I didn't discuss np.arrange method, so np.arrange, let's just call help on it. It will explain to us. So it's like range function, but returns an n-dimensional array rather than a list. And using a non-integer step such as 0.1, the results will often not be consistent. So you can see that if you see this example np.arrange 3, it is creating an array for me. 0, 1, 2, 3, last number is not included. So similarly, if I say np.arrange 3, 7, 3, 4, 5, 6, you can see that this is how it works. You got the idea of np.arrange. Now let me just check this example here. So if I simply just copy this and I call this my array, and if I say instead of or let's x, and so you can see that I will get split because simply my x is print x before split. So you can see that my x is right now this 0, 1, 2, 3, 4, 5, 6, 7. And after splitting, I want it in 3 parts. So it gave me 3, 3, 2 elements. It divided it for me. So this is how array split works, guys. So let's just check our next point. Again, you can pass axis parameter where how do you would like to split this. So if I want it on axis 1, it will do it like this. Let's give it a try and try to understand how it's working. Sometimes it may not work according to what you expected, but you need to understand how it's functioning. So let's see some other operations on Numpy, which are very important, which is np.random, np.dot, and np.add. Mainly np.random and np.dot. So there's one function like sometimes when you have an array like this, and you would like to know where array is equal to 4. So if you use this np.where method, it will give you 356, which is what? Its index 0, 1, 2, 3. 3 is 3, 5, 6. So you see third index, fifth index, and sixth index has elements 4. So what I wanted, where array is equal to 4. So it gave me index. So np.where is quite helpful. Just remember this. You don't need to memorize any of it. You can simply Google whenever you need. Just like I Googled and showed you documentation. For example, let's say I would like to know np.where. And I go to this link and I can see what it is saying, that you pass here condition, you pass here number, and then you can simply get the output. Like you can see here, like here I passed condition only. Here I passed condition only, and main thing is condition. Where true and xy. This is you pass array here, and for example, this is the array, and I said np dot where a is less than 5. I passed a, and then I said what I want output is I would like to multiply it with 10. So first it checked where a is less than 5, which is 0, 1, 2, 3, 4. At these points, a is less than 5, and then I passed a, and then I said multiply with them 10. So you can see that rest of the elements have been multiplied with 10. So just try to understand how it works with these examples, and you can get an idea like how you can use it in your some other scenario. So you can see here output parameter, an array with elements from x where condition is true and elements from y elsewhere. That's how it worked here. It multiplied with 10 on those where it's false. Here condition is true, so it didn't multiply with 10, and rest it multiplied with like this. Again here you can see this example. You have this array and you said a is less than 4, and a is less than 4 up to this point, 0, 1, 2, 0, 2, 0, 3. All these elements are same, rest I multiplied with -1. So this is what I said, what I want. And -1 is broadcast. Why it's -1 is broadcast? So just check these examples once. Like instead of -4, -6, it gave it -1. It gave it -1, and it said -1 is broadcast. And here again, this in this example, you can see both x and 10 plus y is broadcast. So broadcasting, like broadcasting is a different thing. Like sometimes when you have two arrays, one array has a shape and other array has different shape, and you would like to add them, it will make the other array equally size to the other array by broadcasting. So guys, just look at it once. You will get the idea on it. You just need to know about condition here, and that's it. You don't need to understand all the parameters here because you don't use it most of the time, but it's good to know. Now let's go to our next point here, which is what if I would like to convert d type of my array. For example, right now I have this array and I said print array dot d type, and it will give me int 64. But let's say I say that array dot s type, this is a method. I can convert my array into a different type. I can convert my array into different type. And I say print array dot d type. Now you can see that my array type has changed to Boolean type. My array type has changed to Boolean type. If you print your array at this point, array before convert. Now you say here print array after convert. Now you can see that previously my array was 104037, and wherever I have a number greater than 0, it's true, else it's false. So using dot as type method, you can convert your array type. This will also come in handy when you will be working on a data set and you would like to convert any column data type. And let's go to our next which is np.random methods. What is np.random methods? Let's just check its documentation once. np.random. Okay, by mistake I did this choice. Let's just check np.random. So you can see that np.random, there are multiple methods in it. For example, let me just click on this random subject and np.random, numpy.random. It has a lot of methods into this. Let's just check these methods, like randint, random integers, rand. So just go through it once, check these methods. I'm going to discuss some methods from here, and which is first is randint. I'm going to check this method, random dot randint. Let's just check this. Okay, and numpy.random.randint, I've got this method. It takes low, high, size, d type. What does this mean? For example, if we check this example here, it has 2 and size is 10. So it said, you can see that high is none, low is I pass 2. You can see that. So when I set size equal to 10, it gave me 10 elements into this, and it ranges from 0 to 2, and 2 is not included here. 0, 1 only. And when I said 1 only, then it gave me 0, 0, 0, 0, 0 like this. When I said 5, it gave me size 2,4, which is 2 rows and 4 columns, and it gave me 5 elements. Like it gave me numbers up to 5 not included. Size 2,4, and elements here ranges from 0 to 5 not included. So you can see that 0, 1, 2, 3, 4 I have here. So this is how random.randint works. So what I'm doing here, I'm creating a size of 5. An array is going to have 5 elements here, and range of numbers in that array will be 0 to 100. So when I run this, it gave me elements like this. If I say, I have already written this. Let's say I want size 3,5, 3 row, 5 columns. My value ranges from 0 to 100. So you can see that I have an array of size 3,5 where element ranges from 0 to 100. 100 is not included. So this is how my random.randint works. So just check into this, try creating one of your own. Let me just show you one more example here. Let's say this time I keep value like 5, 10. I want an array of 3, 5 where my minimum value is 5 and maximum value is 10. You can see that I have 5, 6, 7, 8, 9. So I hope you got it. Let's just check one more example, which is np.random.choice. Here, what it's going to do is it's going to choose a number from this list. For me. So this time it chose 7 for me. It will choose randomly every time. Not every time I'm going to get 7, but you can see that this time I got 9. So if you keep running it, the value will keep changing. Sometimes it may choose same number also, but it's not always like that. So we have got this random.choice also, and this time I'm going to choose 3,5 array, 3 row, 5 columns, and I'm going to choose numbers from this list. Let's just add a few more numbers here so that it looks more like it looks new example. You see that it created an array for me with size 3,5 by choosing random numbers from this list I passed. You can pass any other array here. It's up to you. So this is how it works, and there's one more example here which is pretty nice. Here it is doing is it has one more parameter p, which is I want an array of size 100. I want numbers in that array from this list by randomly choosing. But the probability of 3 in my array should be 0.1. Probability of having 5 in my array should be 0.3. And probability of choosing n should be 0.6. It means my array will have more 7, then 5, then 3, and then there should be no 9. Let's just check. You can see that I do not have any 9 in my array. I have mostly 7 and then 5 and then 3. So it's a great method and flexibility we have. It's kind of like we can create an we can create a curve of our own. We can create of things of our choice with, even by deciding the probability of any number. So just go through it once, guys. This is very interesting. So this method np.random.normal, you can see here like what this method does is it creates an array for you having values such that if you plot them on the curve, it will create a normal distribution. So let's just check its documentation once. It takes log, scale, and size. So what is log, scale, and size? Log is mean, scale is standard deviation, and size the size we want in our array. So if you check this plot here, like they have shown it, it creates a normal distribution. You can modify these values. What's the mean you want? What's the standard deviation you want of your array? So just keep this in your mind. Sometimes you use it, like you would like to create an data distribution having normal, like having normal curve. So this can come in handy. You can change standard deviation and mean of the curve, and you can see that values changes. So you don't use it much, but just keep in your mind. Sometimes you may see it and you may wonder what it is. So you will get the idea. Now this method np.arrange, we have seen it already. It takes 3 steps: start, stop, step. Start from one step, stop at 2, and at every 0.1 step. You can see 1 to 2. There's difference between 0.1 at every step. So np.arrange is very useful. Keep in your mind. We can check documentation of it once. Like I will show you. But before that, there are some methods I would like to show you, which is, for example, np.zeros, like we are going to use. There are some methods which are very useful. For example, np.zeros, if you would like to create an array of zeros, would like to create an array of 1, you would like to create an array of some other array, but you just want to take its shape. So for example, you want to create an array of zeros by calling np.zeros. You can also define the type and pass the shape and get the array. So these are very handy. Like you can see np.zeros, np.ones, and there are some other methods. Let me show you here. For example, zeros, like here, what you do is you just create an array. For example, you have this x array and you want zeros like x. Zeros like means you want its shape 2, 3, but you want all zeros. So that's how these methods are useful. Now I was gonna show you np.arrange. Np.arrange, since it comes handy. So let's just check. You can see I said start, stop, step. It takes 3 values. So for example, here I want to start from 0, I want to stop at 5, but I want every 0.5 element. You can see that it's weird. It was supposed to give elements like this. Let's just check its parameters again. Okay, let's just check this. I think there's some mistake here. So okay, it's a d type int, and if you say 0, 0.5, 1, 1.5, it should work in a different way. Let me just try this. it's kind of confusing. Sometimes documentation is also hard to understand, and sometimes I just run it like this. So it's correct actually. What it is doing is it is giving me int at every step. So 0, 0.5, and 1, 1.5, 2, 2.5. So it's just giving me like this. Oh, one moment. So length of the output might not be numerically stable. So you can see that there's a warning here. Another stability issue is due to the internal implementation of numpy.arrange. Start plus step minus d type start. Okay, start plus step minus d type start. So this is not stable actually. So it was not supposed to this value. So it's okay. Or there's already warning here. So for example, this is working fine. This is also not working fine actually. So avoid this step as .5. It is giving a integer value. So yeah, integer value it's fine. Then it's fine. -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Again, it's not fine, but it's okay. Main point is these values are stable here. np.arrange like this. This is working fine. So just be careful with this warning thing. And now let's go to our main point. We have seen np.zeros, np.ones. Now, yeah, main thing is addition of true matrices. So this is our first matrix. This is our second matrix here. And you simply call np.add and then pass these two arrays. So how it adds? It adds each element of the first matrix to its respective same position of the second matrix. For example, 1,4 is adding to 5, 2,5 is adding to 7, 3,6 is adding to 9, 4,7 is adding to 11. So the 0, 0 element, 0, 1 element, 1, 1 element, 1, 2 element is adding to its respective position in the second matrix. Same goes for subtraction. 1 minus 4, 2 minus 5, 3 minus 6, 4 minus 7. You can see that -3, -3, -3, -3. So I want you to just write this code and try to understand how it's working. These are very easy things here. The main thing is here is, I will say, the dot product. So for example, I have this one-dimensional array. Actually, right now it's list. So I have this one-dimensional p, q, p and q, and p has 1, 2 elements, q has 4, 5. So when I do dot product formula is a dot b equal to a1 b1 plus a2 b2 if you have two elements in a and b. And here you can see that how it's working. 1, 1 plus 2, 2. It's giving me 6. So here it will give me 4 into 1 plus 5 into 10, which is 14. So in coding, it is very simple to do dot product. For one dimension, it's very easy. Let's just see for 2 dimension. For 2 dimension, how it works is you multiply the first row of P to the first column of Q and then second column of Q. And then you multiply second row of P to the first column of Q and the second column of Q. But in coding, it's very simple. You just pass P, Q and you say dot product and then it does the job for you. So how it's working here? So first row of P has 1, 2. And first column of Q is 4, 6. And then when you multiply 1 into 4 plus 6 into 2, you get 16. And here you can see that I have the 16. Again, first row of P, which is 1, 2, and second row or second column of Q, which is 5, 7. You multiply 1 into 5 plus 2 into 7, you get 19. You have 19 here. Again, second row of P to the first column of Q, which is 4, 6. 2 into 4 plus 3 into 6 equal to 26. And the second row of P multiply with the second column of Q, which is 5, 7. 2 into 5 plus 3 into 7 equal to 31. Here. So this is how dot product works. Just do it once in coding also and manually also to understand how it's working. And similarly, we can see another example. We have different dimensions. So then one point to note is, like in previous example, we had p of shape 2 comma 2 and q of shape 2 comma 2. It worked fine because column of p, which is 2, equal to the row of q, which is 2. These two values must be similar. Column of first matrix, row of second matrix must be similar. And here you can see that column of first matrix P is 2 and and row of second matrix Q is 2. It's the same. The output will be 3, 3. Previously we got output is 2, 2 shape. Now we have 3, 3. So when we do dot product, we can see that I've got the output of 3, 3. So guys, just try to do it manually once, and in coding also you will get it. If you have any doubt up to this point of this tutorial, do comment below. What video would you like to see next? Comment below. And please like and subscribe our channel if you enjoyed the content. Thank you guys.